Hi friends, welcome back to Punsirol Science. If you are reading in class 10 or class 12 science, I hope this video will boost your basic concepts in electricity. If you find this tutorial useful for your study, please subscribe to Punsirol Science and press the bell icon. Also, please share the video link with your friends as well. So today's tutorial is on electric current and potential difference. In this tutorial, I am going to explain you about mobile electric charges, flow of charge, electric current, electric potential difference, conventional current, and electron current. Finally, some sample do-it-yourself questions are given here, and I hope you will be able to solve these sample questions by watching this video over and over again. So let's go to the tutorial. Mobile charges, electric current, and potential difference. Mobile electric charges such as free electrons and free ions are called current carriers because their flow gives rise to electric current. Electrons are current carriers in conductors. In chemical electrolytes, positive and negative ions are current carriers. Electrons and holes are current carriers in semiconductor. A hole is assumed to have equal and opposite charge of an electron. Now I am going to explain how electric charges flow inside a semiconductor. I have considered semiconductor as an example because inside a semiconductor, both mobile positive charges and mobile negative charges are present. A battery is connected across the semiconductor. So in this circuit, the positive terminal of the battery will repel positive charges. Similarly, negative electrode of the battery will repel negative charges. As a result, positive charges will move from X to Y. Similarly, negative charges will move from Y to X. Now in the right hand side, I have given a simple diagram. This diagram shows that positive terminal of the battery is repelling the positive charge, whereas it is being attracted to the negative electrode. Similarly, negative electrode of the battery will repel a negative charge, but the same charge, negative electron, will be attracted towards the positive electrode. In this way, positive and negative charges move in the circuit. In the absence of applied voltage, these charges will move randomly in all directions. As a result, the net current will be zero. In this circuit, I have shown a blue color arrow. The direction of this arrow indicates the conventional current. So what exactly is conventional current? I will explain you later. Now let us see the smallest unit of electric charge. Electric charge denoted by Q is measured in Coulomb. Coulomb is denoted by C, capital C. The smallest unit of charge is equivalent to magnitude of charge carried by an electron, which is given by E equal to 1.6 into 10 to the power minus 19 coulomb. Now let us see how big is 1 coulomb of electric charge. In order to explain this, we have to solve a simple problem. The number of electrons denoted by small letter n present in 1 coulomb of charge can be obtained from Q equal to Ne. So from here, if you put the values of Q and E, it comes out to be 625 into 10 to the power 16 electron. Therefore, 1 coulomb is equivalent to the magnitude of total charges of 625 into 10 to the power 16 electron. This shows that 1 coulomb comprises of a large number of electrons. Now let us see what do you mean by electric current. Measure of the quantity of electric charges passing through a conductor per second is known as electric current. If Q charges has moved during T seconds, then number of charge transfer in 1 second is Q by T. Therefore, electric current is given by I equal to Q upon T, and electric current is measured in ampere. And the instrument which is used for measuring electric current is known as ammeter. How will you define 1 ampere of current? In the equation I equal to Q upon T, if you take Q equal to 1 coulomb, T equal to 1 second, then electric current I become 1 ampere. Therefore, 1 ampere is the current established in a conductor when 1 coulomb of charges flow through the conductor in 1 second. I hope it is clear to you. Further, let us see how many electrons are associated with 1 ampere of current. Again, from the equation Q equal to IT and Q equal to NE, you can write NE equal to IT. This implies N equal to I upon E multiplied by time. Since current is 1 ampere, when Q equal to 1 coulomb and T equal to 1 second, You can find out n, and that numbers comes out to be 625 into 10 to the power 16. This implies that 625 into 10 to the power 16 number of electrons are associated with 1 ampere of current. Now these are some of the important prefixes used in the units of measurement. So when you are dealing with very small physical parameter, you are going to use milli, micro, nano, pico, femto, and so on. And if you are measuring large quantity, you will use the term kilo, mega, giga, tera, peta, etc. These prefixes will help you in quantifying very small quantity and very large quantity very easily. Potential difference. It is the measure of the work done in moving a unit charge through a conductor. If W work is done while moving Q charges, then the work done per unit charge is W upon Q. Therefore, potential difference B is given by B equal to W upon Q, and it is measured in volt. The instrument which is used to measure potential difference or voltage is known as voltmeter. You have already learned that current flow occurs due to flow of charges. In order for the charge to move inside the conductor or semiconductor, some work has to be done, and the measure of that work is known as potential difference. The concept of conventional current was given by Benjamin Franklin. Later, the concept of electron current was given by J.J. Thomson. What is the difference between conventional current and electron current? During 1752 up to 1897 AD, it was believed that electric current is due to the flow of positive charges from positive terminal to negative terminal of a battery through a conductor. And later on, after the discovery of electron in 1897 by J.J. Thomson, it was again accepted that electric current is due to the flow of negative charge electrons from negative terminal to positive terminal of battery through a conductor. So here, conventional current and electron current, they are in the opposite direction. In this circuit, conventional electric current is represented by arrows going from X to Y. Conventional current will flow from positive terminal of the battery through the conductor, and finally that current will come towards negative electrode of the battery. But for electron current, electrons will be moving from Y to X. Well, you have learned the basic concepts of current carriers, electric current, electric potential difference, and conventional current and electron current. So now let us see some of the do-it-yourself questions. And I hope you will be able to answer these questions by watching this video over and over again. Of course, there will be one or two questions which you will not be able to answer. What is the unit of electric charge? What is the magnitude of electronic charge? How big is 1 coulomb of electric charge? How do current carriers move in a circuit? How many electrons are associated with 1 microampere of current? So that work done can also be expressed as W equal to VIT. How much work done is needed to maintain 2 ampere of current in a circuit for 60 seconds? Explain conventional current with an illustration. Why is direction of conventional current opposite to direction of electron current? What causes electric charges to move in a circuit? What do you mean by potential difference? What do you mean by electric current? Do metal ions move to conduct electricity? Give your comment. Power transmission lines cover hundreds and thousands of kilometers under ocean and over land. Do electrons actually move over such a long distance inside the power line conductors? Finally, thank you all for your patient hearing and support to Punsirol Science. See you next time.